frame and machines, force representation, and free body diagram. In most cases, the analysis of frames and machines is facilitated by representing the force in terms of their rectangular component. The analysis of frames and machines is facilitated by representing the forces in terms of the rectangular component. This is particularly so when the dimensions of the parts are given in mutually perpendicular dimensions. The advantage of this representation is that the calculation of moments arm is simplified. The calculation of moments arms is simplified. In some three-dimensional problems, particularly when moments are evaluated about axes which are not parallel to coordinate axes, use of vector notation is advantageous. It is not always possible to assign the proper sense to every force or its component when drawing the free body diagrams, and it becomes necessary to make an arbitrary assignment. In any event, it is absolutely necessary that a force be consistently represented on the diagrams for interacted bodies which involve the force in question. Thus, for the bodies connected by the pin, for example, this picture, the forces component must be consistently represented in opposite direction on separated free body diagrams. We say that when the forces in the part, for example, here AX is opposite and equals to the AX in the other part free body diagrams. For a ball and socket connection between pin, ball and socket, for a ball and socket connection between members of a space frame, we must apply the action and reaction principle to all three components as shown in this picture. The assigned direction may prove to be wrong when the algebraic sign of the component are determined upon calculation. If Ax, for example, should turn out to the negative, it is actually acting in the direction opposite to that originally represented. Accordingly, we would need to reserve the direction of the force on both member and to reverse the sign of its force terms in the equations. Or we may leave the representation as originally made and the proper sense of the force will be understood from the negative sign. If we choose to use vector notation in the labeling the force, then we must be careful to use a plus sign for an action and a minus sign for the corresponding reaction as shown in this picture for the vector analysis. Vector representation. We may occasionally need to solve two or more equations simultaneously in order to separate the unknowns. In most instances, however, we can avoid simultaneous solution by careful choice of the member or group of members for the free body diagrams and by a careful choice of moments axis which will eliminate undesired terms from the equations. The method of solution described in the foregoing paragraphs is illustrated in the some sample problems available in sample problems videos.